All right, good morning, everyone. Welcome back from your extended weekend. Today, we are going to begin our official AP review for the AP exam, which will be on May 22nd. So, we have approximately 4.5 weeks to prepare for that exam. So let's just go ahead and dive in. Again, as the same as last week, please make sure you're taking notes on this video so that you can submit this into the exit ticket folder along with the CFUs from the Zoom call today. So to start, Miguel is a golfer and he plays on the same course each week. The following table shows the probability distribution for his score on one particular hole, known as the water hole. Let the random variable x represent Miguel's score on the water hole. In golf, lower scores are better. Suppose one of Miguel's scores from the water hole is selected at random. What is the probability that Miguel's score on the water hole is at most 5? Show your work. Okay, so looking at this problem here, we need to figure out what type of random variable x is. In order to do that, we need to examine the information that's given to us. So it's going to be beneficial to know what type of information will be given with each type of random variable. So let's just take note of that. So let's just label this in our notebooks as random variables. So the first type that we talked about in Unit 5 was a discrete random variable. And usually in a discrete random variable, we are given probability distributions. Such as a table or enough information to make a table. So that's a very important aspect because sometimes you won't be given a table in a discrete random variable, but you'll be given enough information to make one. And then our second type that we use to calculate probabilities is a normal random variable. And this one's pretty easy because in the problem, they'll explicitly tell you that the random variable is normal. So here, the problem will describe normality. And then the third type we talked about was a binomial random variable. And here, the biggest thing is we know that we have our acronym BINS. But I really want to highlight one of these aspects because that is going to be a good telltale sign that this is a binomial random variable. Here they will give you, most times they'll say, a random number of something is selected. So here, they're telling you in saying that a random number of something is selected, that number is going to be your number of trials. So whether it's people or cars or whatever it may be, that is going to be the number of trials. So if your problem is telling you something about random selection, and then the question asks you about probability, it's a good indication that that is going to be a binomial random variable. So the other aspects we know, we have a binary setting. So we have a success and a failure event. We have independence going on. So whether that is, our test for independence, we take our sample size over the population. Is that less than 10%? So N over the population size, is that less than 10%? Or are we going to draw with replacement? So sometimes they say that there's replacement going on. We really can't do this with people, so that's why we have this method. But if there is a situation where we're taking cards and we replace them, then there's independence going on. And then lastly, there is a probability of success and then that's how we know that this is binomial. Our last type is geometric. And for a geometric, it follows bins similar to binomial. However, there is no set number of trials. So here, if they don't take a random selection, but it follows the rest of these, then we know that it's geometric. Another key word will say until something. So maybe, what's the probability I draw a person until whatever event occurs. So if it's asking for probability and it uses the word until, then it's a good indication that it's geometric. So using these descriptions, let's go back to this problem and see what type of random variable we're looking at. So specifically in this problem, they say that the table shows a probability distribution. So this is a good indication that this is going to be a discrete random variable because it says right here, probability distribution. So I know that this is going to be discrete. So great, we know that it's discrete, but one other thing that we need to figure out, how do we determine probability in a discrete random, for a discrete random variable? So that's another thing that we need to add to our notes. So let me do a different size paper here. So for a discrete random variable, for probabilities, we just add the corresponding probabilities. So in this problem here, they say, okay, what's the probability we get at most 5? So at most 5 means x is less than or equal to 5. So we look at each of these and we say, okay, what are the ones that correspond to x is less than or equal to 5? Well, here's 5, 4, and 3. So we're just going to add up 0.15 plus 0.40 plus 0.25 to give us a probability of 0.8. So that is all there is for part A. And then for part B, we need to calculate and interpret the expected value. So another aspect to each of these random variables is the expected value, as well as the standard deviation. So for the expected value, we know that sometimes they might say expected value, or they might say the mean or the average of x. So here we would take each x value. So from our formula on our reference sheet, it's the sum of xi times p of xi. So basically what that means is we take the x value and then we multiply it by the corresponding probability, and we keep adding until we've exhausted every value in the table. So for example, the first x value is 3 times its corresponding probability, 0.15, plus 4 times 0.4, plus 5 times 25, plus 6 times 0.15, plus 7 times 0.05. And then that will give us our expected value here. So after we calculate this, we also need to interpret the expected value. And this is something that's really challenging for a lot of people because most of us are able to do the calculation, but what does that exactly mean? So let's go ahead and just finish this calculation. Let me go to my calculator. So we had 3 times 0.15 plus 4 times 0.4 plus 5 times 0.25 plus 6 times 0.15 plus 7 times 0.05. Alright, so that has 4.55. So again, the expected value can mean how many times we expect something to occur, or the average occurrence of that event. So here, if we're calculating the expected value of x, which x is defined as Miguel's score on the water hole, then that is going to be the score that we would expect. So we can say we would expect Miguel to score on average 4.55 or on the water hole. So that is our interpretation. So looking at question number 2. So according to a 2018 survey, 74% of employed young adults expect to bring work on a vacation trip. A random sample of 20 employed young adults will be selected. What is the probability that 8 of the selected young adults will expect to bring work on a vacation? Alright, so there's a few things going on here. First, I noticed that they're asking me about probability. So that's a good indication that I need to figure out what type of random variable I'm looking at. So I noticed that they've given me a percent. So they say 74% of employees. So I'm going to write this down. P equals 0.74. And then they took a random sample of 20. So N equals 20. So looking at this, again, I know that I've seen N and P before. I've seen this in confidence intervals. I've seen this in significance testing. I've seen this in describing sampling distributions. But here they're asking us about probability. So I need to unpack in my mind, where have I seen N and P in probability? Well, they say they take a random sample, so I know that that's N. So N is a number of trials. So if I look back at my notes for the random variables, I see that if I have an N value, and they're talking about random numbers, that this is a good indication that this is a binomial random variable. But let me just do bins just to be safe, so I know that I'm not assuming the wrong thing. So for my binary here, they are either bringing work or not. My independence here, well, if I'm just sampling 20 over the population of young employed adults, well, that is a lot of people, especially if we're talking about the whole world. So we can say that this is going to be approximately infinity, which will definitely be less than 10%. Our number of trials here, we've already said was 20, and our probability we've said was 0.74. So we've met the criteria of bins, so we are good to go here. So we're saying, what is the probability that 8 of the selected young adults will bring work on the vacation? So they're saying, what is the probability that X is equal to 8? That exactly 8 people. So I know that since this is binomial and X is equal to a value, I'm going to use binom PDF in my solution. And the order goes NPX, so again in alphabetical order here. So we have 20, 0.74, and 8 as our parameters. So if I go back to my calculator, go to second vars, and then scroll down to binomial PDF, we said 20, 0.74, and 8 gives me a probability of 0.001. So our probability is this. So the probability that 8 of the expected people bring work on a vacation is 1%. All right, so from here, please make sure that you are writing down these notes and that you will be submitting to the exit ticket file on Google Classroom after the Zoom call and after you've added the CFU questions. All right, so please join me on Zoom at 8:20. I will see you all there.